Okay, so graphing quadratics 2. In the last video, I looked at some transformations made to the parent function y equals x squared, which is just a parabola. Looks like this when you graph the solutions. And so we looked at transformations really quickly, like y equals x squared plus 4. What happens is that you shift 4 units up and you have the same exact parabola. So every solution has 4 added to it. We looked at y equals x plus 4 in parentheses squared, and we saw that that moves 4 units to the left. So it's the same shape parabola, just every solution lands over here to the left. So that's a horizontal transformation. This is a vertical transformation. In this video, I want to look at what happens when you put a coefficient in front of the x squared. So I'm going to start out with y equals 4x to the second. I'll make a table of solutions. When you plug in 0, you get 0. 0 squared is 0 times 4 is 0. So you still have the same solution at the origin here as you do here. So there's no transformation up or down. If you plug in 1 and you square it, in the original, 1 squared is 1. Here, 1 squared is 1 times 4 is 4. So instead of going up 1 over 1, you go up 1 over 4. So the solutions are going higher more quickly. When you plug in 2, 2 squared is 4 times 4 is 16. And you can see in the original, when you square it, you just get 2, 4. Here you're getting 2, 16, which is really high. So it's just increasing more quickly. And so what happens when you draw the other side is you're getting a more narrow curve. So that's what happens when you change the 1 in this here to a 4. And as this increases, the higher this number is, the more narrow the parabola is. Okay, so that's what happens when you mess around with the coefficient. I just want to show you what happens if the coefficient had been a fraction, like y equals 1/4 x squared. So when you plug in x's and y's, when you plug in 0, you still get 0. When you plug in, let's say I plug in 2 here. 2 squared is 4. 1/4 of 4 is 1. So now you're going over 2, up 1, as opposed to over 1, up 1. And when you plug in 4, 4 squared is 16, and you take 1/4 of 16, you get 4. So now you're going over 4, up 4, as opposed to the original function where if you had plugged in 4 and you squared, you would have just had 16. So now your values are coming out smaller because you're taking a fraction of them every time. And so you end up with a wider parabola, like this. So once again, messing with the leading coefficient. If it's a whole number, it gets narrow. If it's a fraction, it gets wider. And the last thing I want to look at here is what happens if the leading coefficient is negative. What if I had y equals negative x squared and I made a table of values? If I plug in 0, I still get 0. If I plug in 1 and I square it, I'm going to get 1 times this negative is negative 1. So now I'm getting 1, negative 1 down here. If I plug in 2 and I square it, I get 4, but it's negative 1 times 4, so it's negative 4. So all my answers are coming out negative, so my parabola ends up upside down. So when this leading coefficient here is negative, I get an upside down parabola. So what I'm talking about in this video are what I call y equals ax squared. And a stands for the coefficient in front of the x squared. If it's a whole number, the parabola gets narrow. If it's a fraction, it gets wider. And if it's negative, it flips upside down. Okay, and going back over here, this was what I call y equals x squared plus k. I mentioned this in a previous video, I think. And y equals x minus h squared. So h is my horizontal shifting side to side. K is shifting up and down. And a is sort of what we would call flexing or flipping. So it flexes, it makes it wider and narrower. That's transformations on quadratics.